Episode 29 of the World of FPGA Podcast. How can FPGAs calculate so fast? The secret inside an FPGA is a digital signal processing block. Welcome to the World of FPGA Podcast. I'm your host, David Kirchner, and I will lead you through the world of FPGA. And now, let's begin. Welcome back to our series about FPGA architecture. This episode is all about DSP blocks inside FPGAs. But first, what does DSP stand for? DSP is an abbreviation for digital signal processing. Signal processing is a generic term. It means that a signal stream gets processed. That can be things like filtering, or you can multiplying signals, or you can derive signal, or integrate a signal, or other processes. And at the end of this episode, you know why a DSP block is optimal for digital signal processing. Common parts inside the DSP block are the following. The block usually has around 4 different signal inputs. The width of this inputs depends on the hardware. Often you have things like 18 bits or 20 bits or things like that to have a good number of bits for your signal and for your sign. Normally all the things are working as a signed, for example, as a signed integer. These inputs are going to different parts inside the DSP block. 2 signals get their way to an adder. So we can add up two signals, 2 values at one time, and getting the output of this adder, which is directly connected to the multiplier, or you can also get it to an output. So this is the magic of an FPGA. You have different ways to use your signal. The output of this adder will go to the multiplier together with a third signal from the outside. So you add up you multiply the add up signals times a third signal from the outside, from your control block or from a memory. The output of the multiplication can be added with a 4th signal. So now you have the function add, multiply, and add. And here at the output, you could also use this output, or you can call it output adder, the output adder to add up the output of the adder again with the values you have get from the multiplication. So there you have often a loop back from the output again to the input. And that brings me to the function representation of such a digital signal processing block. The basic function is simple. You can add, you can multiply, or you can subtract. That are the 3 main functions of a DSP block. What you not can do is divide. You cannot divide 2 numbers, and that's the biggest problem in FPGA design. Addition, multiplying, subtraction is easy. It's very easy, but if you want to divide something, then you have to create a big FPGA or VHDL block to do this for you. But there are also some more complex functions. You can build up a counter. As I said before, I call it the output adder, has the possibility to add a value from the output again with the input signal. And the input signal is, for example, 1. And you configure the DSP block that you use this kind of loop. Then you have a 1 added to a 0. The 1 goes to the output, and in the next step, the next clock cycle, this 1 will get to the input, will add it to the input 1, and then you have a 2, and so on. Or you can count up in different steps. That's possible. You can use a combination of all these functions. For example, first add 2 signals, then multiply a 3rd signal, and then add again a 4th signal. That's some kind of filtering. So here are some important facts. The functions in this block only needs 1 clock cycle. And I mean every single function in this block needs only 1 clock cycle. But not the combination. Most time, or in the most designs or FPGA architectures, you have after every single step, so after the adders and the multiplier, you have a register to store the result of the adder or of the multiplication. But the multiplication itself needs only 1 clock cycle, or the adder only needs 1 clock cycle. And as an DSP block can often run with more than 500 megahertz, you have a very, very, very powerful calculation unit, and often you have a lot of DSP blocks inside an FPGA. In FPGA architecture, you have the DSP block often very near to RAM blocks. They are called block RAM or have other names. It depends on the manufacturer and in the architecture. And for digital filter structures, things like FIR filters, so it's an finite impulse response filter. It is quite easy to use this RAM block for the coefficients and for the delayed input signal. And so you can build up some kind of loop for such filters, especially if you have in comparison to the clock, to the internal clock, more or less slow signal with some megahertz or things like that. You only need 1 DSP block for a big filter structure. So you can just optimize your resources usage. Well, and that brings me to the next episode. The next episode, the deep dive episode, is about memory. And then we can see what different kind of memories we have inside an FPGA architecture and what can we use for our functions. Well, I hope this episode was interesting for you to get a deep insight what our DSP block is and what functions you can use. Further information can be found at world-of-fpga.com/WFP029. If you found this episode helpful, please rate it on Apple Podcasts and share it with your colleagues and friends. That's the end of today's podcast episode. Thank you for listening and for your attention. So I say goodbye, here next time, your David Kirchner.